Hello everyone, my name is Frederico Machava. I am student of AIMS Rwanda. I am doing a master in mathematical science. So I'm here today to talk a bit about my work in statistical machine learning course. So in this work, on this task, we have three exercises. Where in exercise 1 we have a data set that we need to solve some task using this data set. Okay, so for the second exercise, we need to solve some task but using data from RStudio. So for that I use package that we call kernlab to find this data. And for the last equation, we're talking about exercise 3, we it's necessary to do some video explain how we solve exercise 1 and exercise 2. So from the next few minutes I'm here to trying to explain how I solve this exercise. Well, for this task we have many graphs to plot and we have main things to do. We use only RStudio to plot the graph and to read some data. So for exercise 1 I started exploration of the dataset. I download the file contain very important information, and I use R Markdown to load it and start to solve our task. So from to know the data set or the size of our data set, I use team, and so I know the number of rows and the number of columns. So for the second part or this part, I plot this graphic to know the correlationship between y versus x. And from this visualization, it's crucial for identify partners or correlation in the data. So for the this part to know the kind of our task, that is classification regression, we it's necessary to look for our value of our y. So this value look like real numbers, continuous numbers, so we can know that we're talking about the regression. And when we're talking about the theoretical part, so I suggest to has function polynomial. Why? Because when I look for my graphic here, it's not like straight line, so I can see this look like function for polynomial. So I choose this function for to start or to explain our model. So it's very important to talk a bit about the optimal model complex. So from using function in our RStudio, we can find that the optimal complexity number is 10, or is ideal. I use graph to compare the training error and cross validation error. And in this graphic we can see that as the model complexity increase, the training error decrease, but the validation error started to stabilize and eventually increase. So this indicates the risk of overfit. So, and we use ANOVA. Let's go to ANOVA. We use ANOVA to assess the significance of the difference between the models. So we can see from our value of p that is very close to 0. So this or the results showed that the difference between the models was statistically significant. Okay, so it's necessary to talk about the second part, second exercise. So for our second exercise, we can see something here. First of all, from this data set, we can see that contain many information and contain more than 50 variables. Okay, and we can see that the non-spam class dominates, which can introduce bias in the in the model. Another thing that's important to say here, we need to for normalization, sparse variables require regularization or robust models such as the tree-based model. So we have many things here, but for the time, I stop from here. Thank you for watching this video. Bye bye.